The objective of the E-plane team is to design a single-seat, multi-engine, home-built, battery-powered experimental aircraft using composite materials that will explore the feasibility of electric aircraft. We did start to build a model prototype, but we didn't finish due to the pandemic. Our first idea consisted of a canard aircraft and a prone pilot. The intention of the prone pilot was to minimize the size of the aircraft, which would minimize the amount of energy needed to make it fly. We found that this was very awkward to create a control system and was also aerodynamically unstable due to interference from the canard to the wing. In our second iteration, we tried to minimize drag by combining the wheels with the structure. We also switched away from a canard configuration. We combined the nose wheel with the rudder and the main wheel with the main wings. Now we found out through investigation that this could cause a lot of bumps on landing and would be unstable on the ground. In our third iteration, we switched to a more conventional tricycle gear. We also combined the tips of the wings at the ends to form winglets. This provides more lateral stability and reduces wingtip vortices. However, we found out through more calculations that there was not enough moment produced by the tail, so it would be unstable. Our fourth and final iteration starts to look more like a conventional aircraft. We've kept most of the features from the third iteration, but we've increased the length of the tail to provide enough stability. Our total weight comes in at 670 pounds, including 200 pounds of batteries, and should cruise at 100 miles per hour. From our estimations, we calculated that we needed 50 horsepower to fly this aircraft. We chose the Lumineer LU-15 motor. It's a popular motor used for large commercial drones. It provides 13.3 horsepower, so with 4 of them we get a total of 53.3 horsepower. To power this, we chose the Samsung 30Q. It's a lightweight battery with a high energy density. It's important to note that at the beginning of this project, these were priced at $3.50 each, but toward the end, they were up to $4.50. The primary method of construction for this aircraft is a composite foam and fiberglass sandwich. This consists of a foam core for compression strength and shape, covered in fiberglass for rigidity. This is a popular method used in experimental aircraft. It allows for complex shapes with relatively simple manufacturing. Some tools we use to analyze and optimize our design are 3D CAD for the layout. This also involved FEA. Pictured is a load analysis of our landing gear and also a load analysis of our wing. We also use CFD, computational fluid dynamics. Some conclusions we drew from this project are battery aircraft are feasible but not practical in most cases. The advantage of batteries is that there's a low operating cost, but the expense is a high initial cost. That is, it's cheap to recharge, but the batteries are expensive. Future development of batteries should make more electric aircraft practical. In the picture is Alice. This airplane is scheduled to go into service in 2022. It can carry 9 passengers at a range of 600 miles.